This is a ninth video out of 10 for the tutorial that describes setting up the simplest simulation with Lumerical software. I would like to remind you that I provide PowerPoint slides supplemental to this video tutorial. This part discusses how to choose FDTD settings, including boundary condition of the simulation domain. By the end of the previous video, we have already created all the objects, excitation source, mesh, and detection monitors that we need for the simulation. Finally, this is the last step we need to make in setting up the entire simulation. This time, we need to define FDTD parameters in the simulation region. Similar to the previous cases, we right-click on the model, we select Edit Object, Setup, and Script. This is going to be the last part of our script. We type select FDTD. Because it is how we will see this item in the setting tree. Again, we introduce a span of all coordinates. I'm just copying X and Y lines from monitor script. For the Z coordinate span, we use H top plus H bottom. And we click OK as we are done with the script. And then again, we need to go to the simulation. This is a part of the top panel, and we select region. FDTD item is created. We look at the settings by edit object. We see that the geometrical parameters are correct. They're populated automatically. In the top mesh settings, we can adjust mesh accuracy. In the boundary condition, we can set up how we handle the domain boundaries. This is an important moment. In our case, we want to select periodic in the X and Y directions. In contrast to the in-plane directions, we select PML in the Z direction. It is a perfectly matched layer in the direction of the wave propagation. PML is an analogy of open in the CST package. This completes our DTD settings and we click OK. This is how our domain looks like. I would like to remind you to save the project. The software package is very stable, but for any package, the crashes occur most often right before we launch the simulation. It is important to save the project right before the run. And then, of course, we can also save it afterwards to make sure results will be available later. Now we go to the tab Run, and we'll launch the simulation. If we expand the window, we see that the simulation shows us a prediction of the simulation time. Right now, it shows an estimate of about 2.5 minutes. We can wait a little bit to see how it goes. Okay, the prediction was not correct, and the simulation ended faster than expected. Also, for some reason, the software changes source size automatically, so it gets twice larger, but it doesn't cause any problem. I'm not sure why it does it, but most likely the software checks for the source size and make sure it has enough area to cover the whole domain cross-section. As always, it's important to save the project. And this completes the 9th video on the numerical simulation with the Lumerical software tool.